Hello, students. Today we're going to be going over cubes and cube roots. So remember to title your page and date your page with today's date. This should be a quick one. Okay, so cubing a number. We've talked about squares and square roots, and we talked about cube roots a little bit in class, and I told you that it would be very similar, except we're going to be using an exponent of 3 instead of 2. So let's begin here where we're talking about cubing a number. Cubing a number is multiplying the number by itself. So just like we did in square roots, we're multiplying it by itself. But this time we're multiplying it 3 times instead of 2 times. Or another way to say it is that we're raising it to the exponent of 3. Okay. So some examples here we have 2 to the power of 3, or we say 2 cubed. This is the same thing as saying 2 times 2 times 2. So we're multiplying 2 times itself 3 times. We're not multiplying 2 times 3. That would be 6. This answer is going to be 2 times 2, which is 4. 4 times another 2 is going to give us an 8. So 2 cubed equals 8. In the next example, I have 3 cubed, which is the same as saying 3 times 3 times 3. 3 times 3 is going to give me 9. 9 times 3 will equal 27. So 3 cubed is equal to 27. Why don't you pause it and try 4 cubed and see if you get it right. Okay, so hopefully when you saw 4 cubed, you know to do 4 times 4 times 4. We're multiplying 4 times itself 3 times. 4 times 4 is 16, and 16 times 4 is going to equal 64. So that is how we would cube a number, by using the exponent of 3. So let's make that note here. We're using an exponent of 3. Okay. Whereas when we were squaring, we used an exponent of 2. Okay. Next section, cubed roots. So again, we talked about square roots, and we had this symbol that looks like a division but is not. This is the radical that we used for square roots. When we're talking about cube roots, it looks almost the same, except on the outside we put a tiny 3 on the outside. That lets us know that we are using the cubed root. So a cubed root, we're just going backwards from what we did up here. We're taking our answer and we're finding the cubed root of that number, which will give us the actual number that we multiplied times itself 3 times. So it's the value that is multiplied by itself 3 times. And I want to point out here, one of the things we talked about with square roots is that you'll have 2 square roots, the positive and the negative. That will not be true for cube roots. There's only 1 cubed root for every positive number, and I'll show you why that is in a moment. Okay, so let's take a look at these examples. Here we have the question being asked, what is the cubed root of 8? So you think back and say, okay, what number multiplied by itself would give me 8? Well, we did that one up here, and we saw that if you take 2 and multiply it 3 times, you get 8. That means that the cubed root of 8 is going to be equal to 2. Okay? And it's only a positive 2, and here's the reason why. If I take a negative 2 and multiply it 3 times, excuse me, well, this negative 2 times negative 2 is going to give me a positive 4. And I multiply that times a negative 2 that's left here. That's going to equal negative 8. That is not the same thing as the cubed root of a positive 8. So this will only have 1 positive answer. It will not have 2 roots, just 1 cubed root. Okay? In the square roots, when we use the exponent of 2, we will have two answers, a positive and a negative. In the cubed root, you're only going to have one answer, the positive. All right, so why don't you pause it and see if this makes sense to you. You try it. Find the cubed root of 27 and the cubed root of 64. Okay, so hopefully you tried that on your own. If you have any questions, please remember to write them down or send them to me on Remind. So the cubed root for 27, well, we did that one up top, and we know that if you multiply 3 times 3 times 3, you're going to get 27. Therefore, the cubed root of 27 is equal to 3. That number that you can multiply by itself 3 times to get the number inside the radical is your answer. The cubed root of 64 then is going to be equal to a positive 4. Next up, we have perfect cubes. So we did a lot of practice in class with perfect squares and finding estimating the value for non-perfect squares. We're going to be doing the same thing with perfect cubes and non-perfect cubes. Okay. So remember that a perfect square is the number that comes from multiplying it by itself 2 times. A perfect cube is the number that comes from multiplying that integer 3 times. Okay, so as long as it comes from an integer, then we're talking about a perfect square. Remember we said that the integers are all of the negative numbers, all of them, -2, -1, 0, 1, 2, 3. So if you take an integer and you multiply it by itself, or multiply it by itself 3 times, you're going to get, in this case, a perfect cube if you multiply it by itself 3 times. Okay. So here's an example that I've already done. We have the cube root of 125 comes from a positive 5. It does not come from a negative 5. So if I take positive 5 times 5 times 5, multiply it, 5 times 5 is going to give me 25 times another 5. It's going to equal 125. Therefore, the cubed root of 125 is equal to a positive 5, not a negative 5. Okay, and the last thing for this video, just like we did for the perfect squares, I'll zoom out a little bit. You're going to make a quick reference guide in your notebook. And we're going to use it just like we used the other one in class. I'm sure you guys found that helpful. So please make sure you have these written down in your notebook. I will be checking your notebook to make sure you have them. We're going to do a quick reference guide for the perfect squares from 1 only through 15. We're not going to go all the way to 20. 1 through 15 should be enough. Just remember that you're multiplying the number times itself 3 times. So 1 cubed is 1 times 1 times 1, which is going to be equal to 1. 2 cubed is 2 times 2 times 2. That's going to be equal to 8. So just remember you're multiplying it 3 times. Use your calculator to make sure that your quick reference guide answers are correct so they can help you. And I'll be checking for that in the next class. See you then.